The bomber was flying straight. Altitude was steady. The formation held its line. Then one engine lost power. Not gradually, instantly. The aircraft pulled hard to the left. The left wing dipped. The nose began to yaw. The pilot reacted immediately. Rudder went down. Hard. The aircraft did not level out. It resisted. The controls felt heavy. The bomber was no longer flying forward. It was being twisted. One side still pushed. The other side dragged. The aircraft began to slide sideways through the air. Speed started to drop. Not fast, but steadily. The pilot kept the wings level. Barely. The control column shook. The aircraft vibrated under uneven thrust. There was no explosion, no fireball, no dramatic damage. But the bomber was already in danger. At this speed, there was no room for mistakes. If the nose dropped, it would not recover. If the pilot overcorrected, the aircraft would spin. The crew felt the change immediately. Loose equipment shifted. The sound of the engines no longer matched. One side roared. The other fell silent. The aircraft wanted to turn. The pilot forced it straight. Every second required pressure. Every correction cost speed. This was not a failure that looked catastrophic, but it was worse. The bomber was now fighting itself. And if the balance was lost for even a moment, the aircraft would roll, yaw, and fall out of the sky. All because one engine stopped. The danger was not the missing power. It was the imbalance. One engine still pushed forward. The other no longer did. The force was no longer centered. It pulled from one side. The aircraft did not just slow down. It twisted. Air hit the wings unevenly. One wing produced more lift. The other produced less. The bomber began to yaw, then roll. The pilot felt it through the controls. Rudder pressure had to stay constant. If it eased, the nose would swing. If it increased too much, speed would vanish. The aircraft was now flying on a narrow margin. Every correction stole airspeed. Every second increased drag. The bomber could not climb. It could barely hold altitude. The remaining engines worked harder. Temperatures rose. Vibration increased. The aircraft was still flying, but it was no longer stable. The crew did not need instruments to know. They felt it in the floor, in the control cables, in the way the aircraft resisted simple inputs. This was asymmetric thrust, not a failure that destroyed the plane, a failure that slowly removed options. Turning was dangerous. Climbing was impossible. Descending too fast would be fatal. The bomber had become fragile. One wrong movement could start a chain reaction. Yaw would become roll. Roll would become a spin. And at this altitude, there would be no recovery. The aircraft was still intact, but the system holding it together was under strain. And it was getting weaker with every second. Holding the aircraft straight required constant force. The rudder stayed pressed, not briefly, continuously. The pilot adjusted trim, then adjusted again. The controls did not relax. They pushed back. The bomber was now flying sideways through the air. Drag increased. Airspeed fell further. The margin before stall narrowed. Every small movement mattered. If the pilot eased the rudder, the nose would swing. If the pilot pressed harder, speed would bleed away. There was no comfortable setting, only compromise. The remaining engines were no longer cruising. They were compensating. Power stayed high. Temperatures climbed. Vibration spread through the airframe. The aircraft began to feel heavy. Sluggish. Unwilling to respond. Turning was avoided. A gentle bank could become a roll. A roll could become a spin. The bomber could not afford that. Altitude was precious. But altitude could not be traded for speed. Descending too fast would remove lift. Climbing was no longer possible. The aircraft was trapped between limits. The pilot focused on one task: keep it straight, keep it flying. Nothing else mattered. Inside the bomber, the imbalance was obvious. The floor felt tilted. Loose objects slid toward one side. The aircraft was no longer symmetrical. It was surviving on restraint. Every second demanded attention. Every correction reduced options. The bomber was still airborne, but it was no longer forgiving. The system had shifted from stable flight to constant prevention. And one mistake, one overcorrection, would be enough to let the aircraft turn against itself. The bomber did not fall immediately, not because it was lucky, because it was built with margin. Large wings generated lift even at lower speeds. Multiple engines meant thrust was spread out. Control surfaces were oversized. They were designed for damage. The aircraft could tolerate imbalance, up to a point. The rudder had authority, enough to counter the yaw. Barely. The airframe absorbed vibration. It flexed instead of braking. The bomber was not agile, but it was stable. That stability bought time. Time to react. Time to avoid panic. The pilot did not fight the aircraft. He worked within its limits. No sharp turns, no sudden climbs, no aggressive corrections. Everything was slow, measured, deliberate. The aircraft responded best when left alone. Small inputs, constant pressure. The bomber wanted to keep moving forward. As long as it did, it stayed controllable. Training mattered here. Pilots were taught what not to do. Do not chase altitude. Do not force symmetry. Do not try to fix the imbalance. Accept it. Manage it. The aircraft could fly damaged, but only if it was respected. This was not strength. It was tolerance. The bomber was surviving because the system still had space left. The margins were thin, but they existed. For now. And as long as those margins held, the aircraft could stay airborne. Even with one engine gone, there was a limit the bomber could not cross. Speed was the first. If airspeed dropped too far, lift would collapse. The wings would stop working evenly. Recovery would be impossible. Altitude was the second. If the bomber descended too quickly, speed would spike. Control would be lost before it could be stabilized. The remaining engines were already near maximum output. They could not give more. If one of them failed, the aircraft would roll instantly. The pilot knew this. He could not turn sharply. He could not climb. He could not maneuver away from danger. The bomber was no longer a combat aircraft. It was a problem being managed. Every decision was defensive. Maintain heading. Hold speed. Protect altitude. Nothing else mattered. The rudder remained pressed. Trim stayed near its limit. The aircraft flew in a constant slip. Fuel consumption increased. Stress on the airframe grew. The bomber was not improving. It was surviving. Any sudden input would break the balance. Any distraction would be fatal. The aircraft demanded discipline. There was no margin for bravery, only restraint. The pilot understood this. The crew understood it too. They didn't ask for maneuvers. They didn't look for targets. They waited. As long as the aircraft stayed inside its limits, it would not spin. It would not roll. It would not fall. But the moment one limit was crossed, the system would fail instantly. And there would be no warning. Only loss. The bomber survived this situation, not because it was powerful, not because it was fast. It survived because the system was not yet broken. The aircraft was designed to tolerate imbalance, but only within strict limits. Those limits were never meant for combat. They were meant for survival. The moment one engine failed, the mission was over. The bomber stopped being a weapon. It became a system under management. Every design choice mattered. Large wings, multiple engines, oversized control surfaces. Training focused on restraint, not heroics. The aircraft did not forgive mistakes. It allowed discipline. As long as the pilot respected the limits, the bomber stayed controllable. The moment those limits were ignored, the aircraft would turn against itself. This is why many bombers made it home damaged, and why many others did not. The difference was not courage, it was understanding. understanding what the aircraft could still do, and what it absolutely could not. Bomber crews were not saved by strength. They were saved by margins, margins that grew thinner with every failure. One engine was survivable. Two engines pushed the system to collapse. Beyond that, physics took over. The bomber did not care about intent. It only responded to limits. And when those limits were crossed, there was no negotiation. Only gravity. That is why losing one engine did not always mean death, but it always meant danger. Because survival was never guaranteed. It was merely possible, as long as the system still held.